Hi, this is Margo. This is Monday, January 15th, 2018, and I'd like to share a couple of short articles with you today. If you've been following my YouTube channel, I've been carrying some articles and information on melting permafrost and changing climate, abrupt climate change, and things like that, and what kind of toxins are being released into the environment as a result of the change in our environment. And these two articles play right into it. They're both from haikumagazine.com. I will put the links in the description below. This first article is called Toxic Thaw Syndrome. Melting permafrost carries unknown dangers for Arctic marine life. And here's a picture. It says melting permafrost is sending soil slumping into the sea, bringing nutrients and pollutions with it. And it's showing how all that permafrost is melting. That permafrost means that it was supposed to be permanently frozen, and in the Arctic and especially Alaska and Canada and a lot of Russia, they have a lot of permafrost. And in Alaska, whole towns and villages are built on the permafrost, and it's as it's melting with our abrupt climate change, the whole landscape is changing in front of their eyes. And so this is just another effect of the permafrost melting. And the gentleman who wrote this article is Dan Zukowski, and this was published on January 11th, 2018. Toxic Thaw Syndrome. So I'm just going to read this to you, or you can go to the website and read it yourself. On a small island in the Beaufort Sea, brown muck slides down tall cliffs, oozes into mud pools, and slithers into the ocean. It's summer, and the permafrost is thawing. As the sediment enters the sea, it clouds the coastal waters, releasing organic carbon, nitrogen, and phosphorus. But that's not all. We found large amounts of mercury and other pollutants, says geoscientist Hugues Lantuet. Anything that is caught in the soils is going to enter the coastal ocean. Some of these contaminants, which also include PCBs, DDT, and heavy metals, fall to the seafloor. Some will be taken into the food web. Previously, researchers have found high concentrations of mercury in polar bears, ringed seals, and beluga whales, for instance. That's a problem not only here on Herschel Island off the Yukon coast, where Lantuet has studied for 15 summers, but also elsewhere in Yukon, as well as in Russia, Alaska, Greenland, and wherever warming air meets frozen ground. Concentrations of mercury in marine animals in the Arctic are 10 to 12 times greater than they were in the pre-industrial period, according to a 2017 report from the Arctic Monitoring and Assessment Program. The report also warns that the thawing of large areas of high-latitude frozen peatlands could release globally significant quantities of mercury into Arctic lakes, rivers, and oceans. The World Health Organization, or WHO, says there is a very high risk of elevated mercury levels among Arctic subsistence hunting communities that rely on seal and whale meat. The WHO estimated that consumption of mercury, a neurotoxin, may be causing an IQ loss of 1 to 13 points in people in these communities. 1/3 of coasts in the world are made of permafrost, says Lantuit, a Parisian who leads yearly Arctic research expeditions for the Alfred Wegener Institute in Potsdam, Germany. It is increasingly under stress because the summer sea ice is disappearing, and that leads to greater wave forcing on the coast. The ice is not there anymore to protect the coast. And here's a picture of the coast of where it's melted. And the caption underneath says, "Scientists from the Alfred Wegener Institute examine a large permafrost thaw slump on Taruk in the Beaufort Sea." Looks pretty melted to me. Lantuit's most recent research reveals some startling facts about the consequences of all this permafrost melt. 8.6 million cubic meters of ice and soil, enough to fill 7 Houston Astrodomes, have been carried off from a 190-kilometer stretch of the Yukon coast between 1952 and 2011. The number of landslides, also called thaw slumps, increased 73% during that time. Joseph Kelly, a geoscientist and sediment expert from the University of Maine, who was not involved in the Beaufort Sea study, says that movements of soil into the sea get reworked by waves for months, perhaps, and will lead to enhanced turbidity, which is local or even regional in scale. Turbid waves from sediment runoff reduce the amount of light that aquatic plants receive, which they depend on for photosynthesis. That affects the fish that feed on them, and in turn indigenous communities that harvest these fish. Nutrient-laden sediments could also create better growth conditions for phytoplankton and a different set of problems, explains Michael Fritz, also with the Alfred Wegener Institute. Organic matter degradation in the coastal zone may also strengthen ocean acidification that causes stress on any species with carbonate shells, such as mussels, Fritz adds. Lantuit is looking to build on the Beaufort Sea research with a major new project named I can't pronounce this. Taruk Inuvialuit for Land to Sea, which is funded by the European Union. Over the next 5 years, the project will see EU scientists working with Russian, Greenlandic, Norwegian, Canadian, and American researchers from 27 institutions to study the consequences of rapid permafrost thaw. The strength here is to start to bind all the knowledge that we have at the Arctic level, because permafrost does not have borders, says Lantuit. And that was a really good article, and this was written by Dan Zukowski for hikingmagazine.com. And the second article I'm going to share with you today is called Sea Level Rise is Unlocking Decades-Old Pollution, Salt Water Creeping Upland, could release legacy fertilizer into the Chesapeake Bay by Roberta Quoke, written on January 10th, 2018, also for haikumagazine.com. And here's the main picture. And the caption underneath says, in a restored wetland in North Carolina, salt-stressed bald cypress trees stand in water that becomes increasingly saline during droughts. The influx of salt water triggers the release of nitrogen from the wetland soil. So here's the article. In 2015, Kate Tully visited farms near the eastern shore of the Chesapeake Bay. She was investigating whether sea level rise had caused brackish water to move upland, a process called saltwater intrusion, evidence of which she found in the form of increased salinity in the fields and surrounding ditches. When the researchers viewed the sites on Google Earth, they could even see white rings around the farms where water had evaporated and left salt. It's crazy, says Tully, an agroecologist at the University of Maryland College Park. You can taste it. You put your finger on the field and it's salty. Saltwater intrusion was killing the area's soy, corn, and wheat, which couldn't tolerate the rising salinity. But as Tully and her team worked in the fields, they discovered an even more worrisome process that was well underway. Their studies suggest that the inundating seawater is triggering chemical reactions in the soil and releasing a long-dormant pollutant, phosphorus. The researchers worry that the phosphorus could reach the Chesapeake Bay and fuel oxygen-sucking algal blooms that kill fish and crabs. The phosphorus is from chicken manure fertilizer, which farmers have been laying on the fields ringing the Chesapeake Bay for decades. The region, one of the oldest farming districts in the colonial United States, is also part of the broiler belt, known for its intensive poultry industry. Phosphorus has accumulated in the soil, but now it may be released. Tully doesn't believe that the farmland nutrients will flood the bay all at once, but firehouse moments could occur, she says, when storms push seawater inland. The situation brings to mind other examples of how the long-term effects of climate change could trigger local events that amplify the environmental damage. For instance, warming of the Arctic permafrost and seafloor could cause the greenhouse gas methane to be released, driving further warming. Permafrost thawing, similarly, could release long-stored contaminants such as mercury. While nutrient pollution would not create a feedback loop that speeds up climate change, as methane would, Tully thinks the effects on the bay could be dramatic. Is there a possibility for us to tip the ecosystem into a different ecosystem? Says Tully. Yes, definitely. To come to their conclusion, Tully's team analyzed the soil at 3 farms in Maryland and found that phosphorus, bound up in the molecule phosphate, appeared to be moving from the fields toward ditches. From there it could then flow into creeks connected to the bay. Salt water is likely unlocking phosphate from the soil through a series of chemical steps. In soil with plenty of oxygen, the phosphate in fertilizer can bind to iron. When the ground becomes waterlogged, soil pores containing oxygen fill with water instead. Under these conditions, iron releases the phosphate. Sulfate, an ion in seawater, then binds to iron, leaving phosphate free to move around. And here's a picture of how the crops and trees have been damaged by the seawater. Tully found that average phosphate levels in ditch water in nearby marshes are about an order of magnitude higher than the U.S. Environmental Protection Agency's regional water quality guidelines for phosphorus. They're screaming high, says John Komanowski, an ecologist at Florida International University in Miami. Levels of nitrogen, another fertilizer nutrient, in the study area were less worrisome, says Donnie Weissman, an ecologist on Tully's team. Nitrogen has been the main nutrient polluter in the Chesapeake Bay, but phosphorus may become an increasing problem because it sticks around, says Chris Kraft, a wetland ecologist at Indiana University, Bloomington. Microbes can turn nitrogen-containing molecules such as ammonium into nitrate, which then gets converted into nitrogen gas that can be released into the atmosphere. Phosphorus doesn't have a similar process. There's no way to take it out, Kraft says. Tully's team doesn't yet have evidence that the nutrients have reached the Chesapeake Bay. Overall, the bay's phosphorus levels have declined over the past 2 decades, thanks to efforts to reduce fertilizer use on farms, Weissman says. But she is concerned that this legacy fertilizer could pollute the bay in the future. Ultimately, the amounts of nutrients released because of saltwater intrusion are probably small compared to runoff of recently applied fertilizer, Kraft says. He compares the situation to giving another pack of cigarettes to a chain smoker. This is an added sort of insult, he says. Kraft predicts that the damage will vary from year to year. But the problem goes beyond the Chesapeake Bay. Marcelo Ardone, an ecologist at North Carolina State University, has studied a former farm that was converted to a wetland in North Carolina, where droughts increased the salinity of the wetland and appeared to have triggered the release of legacy nitrogen. Ardone estimates that if the sea level in the region rises by 1 meter, which could happen by 2100, about 18,000 metric tons of ammonium could be released. That's roughly half the amount that the Mississippi River dumps into the Gulf of Mexico annually. Ardone cautions that he doesn't know how quickly such a release would happen, but it could be a serious problem, he says. Legacy fertilizer releases could happen in other coastal agricultural areas as well, such as Texas, Alabama, Georgia, and California's Sacramento Valley, Komanowski says. Saltwater intrusion also is affecting Bangladesh and Vietnam, Tully notes. Farms there probably have less fertilizer stored in the soil than countries with a longer history of industrialized agriculture, but will still suffer crop damage, she says. To stop the flood of nutrients, Tully's team is investigating the ability of salt-tolerant crops such as rapeseed, which is also known as canola. That's what they make canola oil out of. And perennial grasses to grow well in the conditions observed at the Maryland farms. These plants could suck up phosphorus and nitrogen. Fields could later be converted to wetlands, which are better at retaining the nutrients. But most farmers in the area want to keep farming, Tully says. Scientists could still lack critical numbers, such as the amount of legacy fertilizer nationally and globally, Ardone says. This is an important risk that we haven't fully gotten a handle on. And that's the end of that article, and that was written by Roberta Quoke for haikumagazine.com. So here's an overview of that article again. So these were two very good articles. They're short and to the point, but very good, from haikumagazine.com. I just found them. And my name is Margo. I'm a hypnotist, holistic life coach, and empathic spiritual healer. Here's my healing website. Here's my Green Living Coach website. I'm also just became certified as a Green Living Coach. If you'd like to book a session for Green Living Coaching, I can help you identify toxins in your food and in your environment that may be affecting you and affecting your health, and offer natural solutions and non-toxic solutions. And here's my healing website for spiritual healing. I've been focusing on implant removal and spiritual healing. That's margoshealingcorner.com. My Green Living Coaching, you can just go there from Margo's Healing Corner right here. There's a link. It says Green Living Coaching by Margo. You just click on that. It takes you right to Green Living Coaching, and it's also at glc.margoshealingcorner.com. So, I'm just saying, time is short. The earth is changing very quickly. It's changing right before our eyes. We don't know how much time we have left. So I encourage you to, if you haven't done so yet, get right with God and Jesus, and do a spiritual life review, because time is short and none of us know exactly how long we have. So until next time, my name's Margo. Go in peace. God bless. Goodbye.